Hello again, guys, it's Mr. Washahi again, and this is going to be a continuation from our previous tutorial with prime factorization, and this one's going to be real quick. This is just going to show you how you can reduce fractions with prime factorization, or in other words, simplify or put a fraction in lowest terms, whatever terminology you'd like to use. Example I'll use is 30 over 45. So a lot of students, they like to just start dividing by a number until they can no longer divide until they get prime numbers or they don't have a similar factor. That's fine, but prime factorization I think might take you just a bit longer, but I think it'll be more accurate. So let's use 30 and 45 as an example. What I'm going to create a factor tree for 30. So two numbers that I can multiply to give me 30 are 5 and 6. I can't break 5 down because it's a prime number. However, I can break 6 down into 2 times 3. And both of those are prime numbers also. Alright, let's do the same for 45. So I could do 5 times 9, so 5's prime. And with 9 I could do 3 squared, or bury it 3 times 3. So I'm going to write those in my fraction. So 5 times 2 times 3, that represents the 30. And then 5 times 3 times 3. So what I'm going to do now is cancel out any similar factors. So I've got a 5 right here, so I'm going to cancel out the 5 in the denominator. I've got a 3 right here, I'm going to cancel out the 3 in the denominator as well. So that leaves me with 2/3. And this will be the reduced version of 30 over 45. Alright, let's do another example. 16 over 32. Alright, well, let's do a factor tree for 16. Let's do 4 times 4. I could break those 4 downs into 2 times 2. I'm going to rewrite my 4 2's. Alright, let's look at 32. Let's do 2 times 16. And I could do 4's. I could do a couple of 2's on each one. I'm going to circle all my prime factors. So here, if you look at it, you got 2 5 times. I wrote my 5 2's and multiply them. So again, I'm going to cancel out whatever I have. So I got 2's right there, 2's right there, 2's right there, and then 2's right there. If you notice, I've got nothing left over in my numerator. However, I can't write 0 over 2. That's not a true fraction. That would be 0. You have to remember that in every number, you could multiply it by an invisible 1. Okay, so if you ever left out with no factors in one of either your denominator or numerator, remember there's always that invisible 1, so it's actually going to be 1 over 2, or 1/2. So 16 over 32 is equivalent to 1/2. Okay, so again, reducing with prime factorization might take you a bit longer, but it's going to be so much more accurate, and especially with numbers that are kind of large where you don't want to just keep dividing over and over and over. Alright, good luck.